All right, hi kids. So today what we're going to be doing is we're going to be working on a video lesson on 112, which is about exponents and their rules. This should be a review lesson. What you can do with this is you can pause and fast forward depending on where you're at. Again, I'm going to kind of do the lesson. I'm going to show a couple examples, and then for the most part, I'm just going to ask you to pause, work on some example problems, and then play it so you can see the answers, check your answers, and then ask questions tomorrow when we're in class or before school. So let's get started. All right, here we go. So our target today is you're going to be able to use exponent rules correctly, and you can use the Pythagorean theorem to find missing side links. So we're going to be using those two things today. So on your note sheet, um, you see the rules here. So we have powers of product of powers, power to power, power of a product, all of these. All right. So the rule is there. All right. What I'm going to do is I'm going to add in a couple extra things. So we're going to start with the first one, product of powers. So product of powers is basically saying that when you have two exponents or two terms with the same base. So in this case, let me just kind of explain. So if we had like a to the m power, the a, this is a base, and the m, this is your exponent. All right. Since our base is the same, so in this first one, if our base is the same, and you see two exponent terms being multiplied, all you do is you just add the exponents. The base stays the same, but you add the exponents. So an example that you can write down is x to the third times x to the second, all right? So we are multiplying our two exponents together, which means we are adding the exponents. So it's going to be 3 plus 2, which is 5, not 6, all right? So your base stays the same, you just add the exponents. Second is power of the power of a power property, or power to a power property. And what that means is anytime you have an exponent that's raised to a second exponent, you're just multiplying. I like to think about it like you're distributing. All right, you're going to distribute that exponent in to every term that has an exponent, or to every term. So an example would be x to the fifth, and then raised to the second power. So x to the fifth raised to the second power. So you're just going to distribute this 2 into the 5. So it's going to be x to the 10th power, because you're multiplying 2 times 5. You multiply your exponents together when you have an exponent raised to another exponent. And a very, very similar property is a power of a power. So it's basically, or power of a product. And the reason it's different, power of a product means that you have multiple terms in here that are being multiplied together. So what you do, similar to the one above, you're actually going to distribute this exponent to both terms. All right. Now, if you look, both these terms right here, a and b, actually do have an exponent. Their exponent is a 1. So really, it's a to the first power times b to the first power raised to, well, in this case, it's the m power. So you're just distributing that exponent in. So if we were to create our own example, all right, if we were to create our own example with maybe a different variable, let's say x to the second power times y to the third power, all raised to the fourth power here, the product, or the power of a product property, says that we're going to distribute this 4 to both terms, the x and the y. So our final answer is going to be, ooh, that's moving on me. All right, let's get rid of that. X to the, sorry, I'm using this pen on my computer. It's not working right. X to the, because it was the 4th, x to the 8th times y to the 12th. All right, and that's how you do that. You just distribute that exponent on the outside. So let me just erase that so you can see what that is. All right, it was a 4th power. So, all right, come on, where's that pen? All right, so there you go. So now, all right, power of a quotient. Now, quotient means division. So anytime you have two exponents being divided by each other with different bases, but raised to an exponent similar to the last one, you distribute that exponent that's on the outside of your parentheses to both the numerator and the denominator. So again, an example, all right, an example would be like x to the third, come on, third over x, or sorry, let's put a different variable here, y to the 5th, then all raised to, let's say, to the 8th power. So we're going to distribute that 8th everything. So since we're distributing, we're multiplying that exponent. So it's going to be x to the 24th, y to the 40th. Okay, now let's just leave that here. Okay, done. Understand that you are distributing when your base is different. All right, when your base is different. If your base is the same, I would recommend simplifying inside first and then doing your distributing. All right. Now, take a look here. Something a little similar, but a little different. All right. Power of a quotient. All right. Power of a quotient. Now, power of a quotient means that, all right, our base, unlike the last one, is the same here. All right. So if our base is the same, what we're going to do, just like what we did up here for product of powers, all right, we're going to keep the base the same, but we're just going to subtract numerator from denominator. All right, numerator from denominator. So if we did, let's do like x to the 5th over x to the 3rd, all right, what we're going to do is we're going to take numerator minus denominator. So we're going to go x to the 2nd power, top minus bottom, top minus bottom. All right, here we go. Two more, and then we can do some examples. So what we're going to do here, negative exponent. Now here's the thing, all right, negative exponent. You cannot leave your answer with a negative exponent, all right? Exponents are a way to show multiple multiplication, all right? So if you have a negative exponent, you can't show something negative 6 times or negative 5 times. So you can only show it a positive number of times. So when you have a negative exponent, what we do is we move it and lose it, all right? And what I mean by that is all numbers, all variables can be written as a fraction over 1. So if your number starts with a negative exponent, we're going to move it to its opposite location. So if this was a to the nth power or negative nth power, we put it over 1 and we move it to the denominator. All right, so we move it to the denominator, and what happens is we lose the negative exponent. The negative exponent becomes positive, it's moved to the denominator, and we just put our answer over 1. Or if our negative exponent starts as a fraction, we can't leave it as a negative exponent. We have to move it upward to the numerator and put it over 1, and our negative exponent becomes positive. So if we need an example for this, all right, we can do let's do x. I like using the variable x to the negative 3rd power. All right, that's negative to start off with, negative exponent, so we need to change it. So the first thing we're going to do is we're going to put this over 1, because you can put anything over 1. Now we're going to move it to the denominator. So it's going to be x to the positive 3rd power is in the denominator, and you're just going to put that over 1. So 1 over x to the 3rd power. And now lastly, all right, 0 exponent property. So 0 exponent property means anything raised to the 0 power will always equal 1. Always equals 1. Doesn't matter what it is. If it's a variable, a number, symbol, doesn't matter. It's always equal to 1. All right, so if you did a, we already have a there. Let's go b to the 0 power, that's 1. X to the 0 power, that equals 1. Smiley face to the 0 power, that equals 1. All right, anything to the 0 power equals 1. So with that little refresher, now let's do a couple examples. So I've highlighted a couple examples that I'm going to do with you, and then I'm going to pause this, and then you can do these problems and then check your answers. So first example, we got a to the 3rd times a to the 7th. So this is the power multiplication property, all right, product of powers. So what we're going to do here is all we do is we just keep our base the same, it's an a, and we add the exponents, we add them. So 3 plus 7 is 10. Boom, done. That's it. All right, add your exponents. Number 6, this is a quotient, so you're dividing. Base is the same, so we know, all right, our answer is going to have a base of 7, or a base of s, and we're going to go numerator minus denominator, 8 minus 3, and this is 5, so it's s to the 5th power. You are subtracting, so 8 minus 3. Now, number 9, all right, number 9, very similar to number 6. Base is the same, so I know my answer is going to be an x, but check this out, all right? I know it's going to be an x. So I go numerator minus denominator, so 7 minus 13 is actually a negative 6. Now, many of you want to leave this as an answer, but hopefully you're saying to yourself, wait, didn't Mr. Wildman just say negative exponents we can't leave? That's true. So because this answer is a negative exponent, we've got to change this. We've got to move it and lose it. So now we got to say, all right, Well, I'm going to put this over 1. This is technically an answer, but it's not a correct answer because we need to move this negative exponent. We need to move it to the denominator to make this a positive x to the 6th power, and then we put that over 1. So this is your answer here, 1 over x to the 6th power. And that's your simplified answer. All right, here we go. Let me get a different color because it's pretty close here. So number 10, you got 3 to the negative 2, all raised to the negative 4. So this is a power raised to another power. So when you do a power raised to a power, this is distributing. So that means we're multiplying here. So this is going to be 3, and then negative 2 times negative 4 is positive 8. Now, unlike the last problems where you've had variables as your base, our base is a number. So since we have 3 to the 8th power, that is correct, but you always want to simplify. You always want to kind of know what that value is. All right, so we go 3 to the 8th, put that in your calculator, and you should get 6,561. And I would like you to leave your answer, as long as it's not a ginormous number where, you know, your calculator goes like 6.3 e to the blah, blah, blah. Just write out the number. If it's ridiculously large, leave it as, you know, something to the ridiculously large exponent, okay? So that's number 10. And our last example before I'm going to ask you to pause this and go and do these on your own, is number 14. All right, now number 14, very similar to number 10, all right? This is a product of powers. So that means that we are going to take all of our terms and we're going to distribute this third power to all of them. So when we distribute, we're multiplying our exponents. So we're going to go a to the 2 times 3 is 6, b to the 5 times 3 is 15. And that's your answer. All right, so what I'd like you to do right now, pause this video, work on the remaining problems here on these examples, and then restart it so you can check your answers, okay? Cool. All right, so now you're restarting the video, so you've already got these done. Let's check at these answers. Let's see what we got here. So I got it kind of covered up. So here we go. Ooh, come on, man. There we go. So there are our answers for 2, 3, 4, 5, 7, 8, 11, 12, 13, 15, 16. Let's see if we can get the bottom. All right, 17, 18, 19, 20. Now notice, if you need to pause, but notice how on number 18 over here, number 18, I did not give you a number because it was ridiculously large. All right, and notice on number 20, all right, I put it as a repeated decimal. All right, don't just round. All right, if you can write it as a repeated decimal, do so. When I ask you to round, I usually will have you round to 2 decimals, which we'll see on the next part of this review. So there we go. Hopefully you got them right. If not, circle it and we'll come back to it tomorrow. Ask that question. All right, here we go. Come on now. There we go. So the second thing we're going to work on today is the Pythagorean theorem. Now, the Pythagorean theorem is used to find the sides of right triangles. Now, right triangles, that's important because you can't use this on any other triangle but right triangles. The Pythagorean theorem is the formula a squared plus b squared equals c squared. Now, in that formula, a, b, and c are all values of your triangle, okay? So in a right triangle, all right, you need to always figure out where your c is. Your c is always the hypotenuse, which means it's the longest side, all right? Now, how do you find your longest side? Well, the one cool thing about right triangles is that there's a right angle, and that right angle kind of acts like an arrow. It always points at your hypotenuse, HYP, hypotenuse, all right? And that's our c value. That's C. That's always your side C. Now, the other 2 sides of your right triangle are called legs. This is a leg, and this is a leg. Now, it does not matter which one you're going to refer to. They're both legs, so it doesn't matter which one you call A and which one you call B. All right? You just need to make sure that you know where C is. C is always across from your right angle, and then your money. So how I do these problems, all right? So notice number 1, I have a right triangle, so I'm thinking, oh, I need to find this missing side x. They give me a leg, they give me a hypotenuse, and they give me this. Now, if you're like, I don't know what a leg, hypotenuse are, find your right angle, it makes an arrow. It always points at your hypotenuse or your c value. So that means your other 2 sides that are maybe a variable or maybe constants that you're working with, those are going to be your a and b. Now, it doesn't matter if you want to flip-flop the 4 and the x being a and b, it doesn't matter. But knowing what a, b, and c are, now we can use the Pythagorean theorem, which is a squared. So in this case, it's going to be 4 squared plus b squared, which is now x squared, equals c squared, which is 13 squared. So now that we've written it out, all this is now is a multi-step equation. So we're first going to simplify. 4 squared is 16 plus x squared equals 13 squared. Oh gosh, come on now. Oh man, of course this happens. Let me erase this. I don't know why this is working like this. All right, if this does it again, I'm going to shortcut it. Here we go. 16 plus x, come on buddy, plus x squared equals 169. Oh my gosh. All right, this is going to start acting funky. So you're going to subtract 16. You're going to get x squared equals 1. Let me get it in the calculator. I don't even need a calculator. What is it? 153. Now, all right, x squared equals 153. Now, here's the deal. We must square root at the end. We must square root. We have to know what x value is. Now, x equals, when you do the square root of 153, you're going to realize that it's a decimal because it's not a perfect square. So you can leave your answer as a square root of 153. Or for those who need to simplify a value, all right, we're going to approximate what the square root of 153 is. All right, so we're going to do square root 153, and it's approximately 12 point, now we're going to round to 2 decimals. It's 369, so it's 37. And it's approximate, says it's not equal to, but it's about. So one of these two answers is good. But if you said x equals 12.37, that would be incorrect. You need to put your approximate symbol there. All right, here we go. Last problem, number 2. Same thing, Pythagorean theorem. So identify where your right angle is. It points at your c value. So that means our other two sides are a and b. Again, doesn't matter what a and b are, you just need to know where c is. So when we put this as our write out our equation, we're going to go a squared, so 15 squared, plus b squared is 6 squared, equals c squared, which is x squared. Now the one nice thing is when your c is your variable, all you're going to do is simplify and combine. So 15 squared is 225 plus 6 squared is 36 equals x squared. We're going to combine 225 and 36, so we're going to get 261 equals x squared. And just like the last problem, we need to solve for the value of x. So we got to take the square root. And the square root of 261 is not a perfect square, so you can write it as x equals the square root of 261. Or you can approximate, if you want to see it as a number, the square root of 261 is 16 point, now we're going to round to 2 decimals, 16, which is 6. Okay, so one of those two answers need to have the approximate symbol if you're going to turn it into a decimal. So there we go. Notes are over. Your homework tonight is to finish the rest of this. All right, pause, do the problems at the homework, and then you can see the answers. Now you can already see the first 3, but pause it, try it, and then check your answers. Okay, here we go. For those who have done it, here are the answers. All right, so take a look at that. All right, I'm going to scroll down number 11 and 12 so you can check that out. All right, ooh, come on now. There we go. So you can see 11 and 12. Again, I'll accept one of those two answers. Always round to 2 decimal places if I don't tell you. All right. So any questions, please come and see me in the morning. Other than that, great job, and I will see you tomorrow. Have a great night.